Hi friends, welcome once again in another episode of derivative. Right, up to this point we have learned the derivative of the sin x, derivative of cos x we learned in previous videos. Now we are going to find out the derivative of the tan x, right? And before proceeding, let me show you the graph of the tan x. How is exactly the graph of this tan x is like this, right? And derivative of the tan x at any point, suppose this x part, or this actually this x represent the angle, right? And these all are angles, angles are varying. Actually this angle is increasing here. So here angles, if you take any angle, suppose about here I'm going, right? Let me do with the red color. Suppose here, right? Suppose I want to find here x has value, a certain value here has, right? Here is certain value up to this, suppose here, right? Suppose if I want to find the derivative over here, suppose there is some certain value of x, right? So certain angle value here is now. So the derivative at this point means simply the slope of this curve at the particular point, or you can say the tangent at this point, right? The slope of the tangent at this point is called the derivative at this point. Or in another way you can say derivative is simply the rate of changing of this function dy by dx, or delta x upon delta y, so delta y upon delta x. That's a small change in y, small change in x, right? How this curve is changing, how this function is changing at the particular point, right? This rate, this rate of changing the function at a particular point is the derivative, right? So you can take anything, right? Anything in over here, and how it is changing exactly, that shows the derivative, right? If you want to find out over here, then just find out the tangent and the slope of the tangent, right? Still I'm not drawing perfectly. It is something like this, right? So straight line, the tangent at this point, and the slope of the tangent is just the derivative at the particular point, right? So actually the derivative of the tan x means that thing, right? So I hope you understand. The graph of the sin x and cos x is not it's totally different than the graph of the tan x, right? So tan x is totally different, it has something different graph. The sine and the cos we used to generally get in the in the same, right? Like this is it is to move, right? In cos x we used to get like this, means moving like this, but here we get the different figures, right? So it is something different. So let's go to find out the derivative of the tan x, right? So here our function is, right, our function fx is or we can say we generally say y also to this, right, is tan x, right? And in the chapter of limit, what we had learned, sorry, in the chapter of derivative, in introduction of the derivative video, what we have learned, that derivative of the any function, that is f prime x, is equals to limit when h tends to 0. Here h is the very small change in the x, right? This very small change in x, actually suppose this must suppose we are taking the distance, suppose up suppose somewhere this is the x part, right? And then the small, very small delta x change in x, right? This means this generally we used to represent by the h. It's very small change in the x, very near to the x. Actually we are taking the another point. So a limit when h tends to 0. I know you are understanding this because since initially you may be watching this video, right? So let's go ahead. Limit h tends to 0, that is, right, f of x plus h minus f of x whole divided h. This definition we had learned, right? This is the definition of derivative exactly. And now we are going to find out the value of the derivative of the tan x by the first principle method, right? So let me go ahead. I'm just applying this definition or this formula for this function, right? So here now the function f of x, right, or you can also say that f prime x, or you can also say tan x, right? Derivative of tan x, right? Derivative of tan x, you can say like this, right? Derivative of tan x. What is the derivative of tan x? That we are going to find now, right? Or you can say dy by dx, or d tan x by dx, right? What is that? We are now going to find out, right? So let's go ahead. Here our function f prime x, or dy by dx, will be now equals to, right? See in this figure, right? Okay, well in this figure, so it will be now limit h tends to 0. Now see, this is such a function, fx is such a function, right? Whenever you insert something, right, suppose you're inserting x, then you'll be getting tan x, right? And in the place of x, if you're inserting suppose p, then you'll be getting tan p, right? Here will be tan p. If you're inserting here q, then you'll be getting tan q, right? And suppose if you're inserting here suppose an orange, then you'll be getting tan orange. If you're inserting an apple, then you'll be getting tan apple, right? Whatever you will insert, you'll get like this. Now here in this question, I'm going to insert the x plus h, right? So I'll be getting tan x plus h, right? So just like here, so it will be now tan x plus h, right? And that's fx minus fx. So here minus fx is just fx is just equals to tan x, so it will be now tan x whole divided by h, right? So as we used to do, how to do further, we used to do in the trigonometry that we used to convert the tan or cot everything into the sine and cos. So again I'm going to convert this tan into the sine and cos, right? So it will be better to calculate this easily. So it will now sine x plus h divided by cos x plus h, right? Because tan is just a ratio of, you can say it's sine and tan, sorry, sine and cos, right? That's actually if you go, then it will be perimeter to the, sorry, perpendicular to the base, right? It's just, so here also tan x, that is sin x divided by cos x, right? And then whole divided by h, right? So now how to do, let me show you here something. In small classes, what we used to do, if there was 2 by 3 minus suppose 1 by 4, then what we used to do, we used to take the LCM of this 3 and 4, right? So the LCM of the 3 and 4 is 12, and then what we used to do, we used to divide this whole 12 by this 3, and whatever we used to get, we used to write here we used to write. So I'm doing the same thing. So 3 by 3 I'm dividing this 12, so I'll be getting 3 fourths, so the 4, and whatever we left here, by that we used to multiply this. So 4 to the, it will be now 4 times 2, right? And whole minus, again we used to divide this whole 12 by the 4, so we'll be getting here 4 3s are, and whatever we left here in numerator, that will multiply here, right? We used to do like this, and we used to solve. So in the same way I'm going to solve here, right? So what I will be getting, the LCM of this part and this part, I will be getting cos x plus h, right, times cos x, right? And then this cos x plus h now divide whole this, and when this cos x plus h divide this whole part, this cos x plus h, I mean this part and this part will cancel out, and we'll be left with the cos x, and then here cos x will be here left. As this 3 was dividing this whole 12, then the 4 was left, right? Then we used to write the 4 here, so cos x now times whatever it is left, the sin x plus h is left, as here 2 was left here, right? So we multiply by the 2, so here we have we are left with the sin x plus h, so sin x plus h will multiply now, right? And again minus, right? Minus in the same way, right? Cos x, this whole cos x, this cos x will divide this whole part, so cos x and this cos x will cancel out, right? But I'm not cutting here exactly, we cannot cut, I'm just doing this. You can calculate this in math in your mind, right? So cos x, and we'll be left with the cos x plus h, right? Cos x plus h times whatever we are left, just like here we are left with the 1, so here we are left with the sin x, right? And whole divided by this h. Oh, I forget to take the limit h tends to 0, right? Now oh, I got the sort, okay, fine. Now now I'm writing it properly, it's not looking nice. So limit, right, h tends to 0, sin x plus h times cos x. Cos x is not looking nice, that's why I'm just arranging it properly, right? Minus cos x plus h times cos x plus h, just wait, okay, sine, I'm writing the sine first time and then cos another time later, right? Cos x plus h, right? And then the whole divided by this h is here, and this cos x plus h and cos x will comes downstairs, right? Cos x plus h times cos x, right? Now what to do further? look at this properly, my friend. Just look properly, you'll see something there, right? X plus h, sine x plus h times cos x minus sine x times cos x plus h. Don't you look, it's looking just like this now, sine a times cos a, and then minus, right, sine b times cos a. So what is this? Do you remember what is this exactly? Yeah, you're right, exactly what we have learned in trigonometry chapter, that this is the formula of sine a minus b, right? So the formula of sine a minus b is sine a times cos b, right? This is cos b, and sine b times cos a, right? So sine a times cos b minus sine b times cos a. I'm just using the formula of sine a minus b over here, so it will be exactly uh, limit s tends to 0, right, and then sine a, right, that x plus a is working as a, so x plus h minus this x is working as b, so minus b, right, and then whole divided by h times cos x plus h times cos x, right? Now what we can do, we can easily cut this part, right? This x and x we can cut, sorry, I cut the h, this x and x will cancel out, and now what we can write, limit h tends to 0, right, sine h upon h, right, and times 1 upon cos x plus h times cos x, right? And again we're getting something different thing here, right? A very important thing, limit h tends to 0, see, sine h upon h, that is what we had learned exactly in limit chapter. When theta tends to 0, sine theta upon theta is equals to 1. So here sine h upon h, when h tends to 0, sine h upon h will be equals to 1, right? And h, when h tends to 0, so it will be now 1 upon cos x plus 0 times cos x, right? So it is exactly 1 upon cos square x, that is equals to sec square x, right? So the derivative of the tan x is equals to sec square x. Now what I can write, f prime of tan x, or you can simply say derivative of tan x with respect to x, or simply you can say dy by dx is equals to sec square x, right? So this is now we got the value of the derivative of the tan x, right? And in now further problems, right, in derivative problems related to trigonometric problem, right, trigonometric derivative problems, we will be using this formula as a standard formula, right, in other problems. So remember this, the derivative of the tan x, what is exactly derivative of the tan x, sec square x. So you have to keep it in your mind, right? We'll be using as a formula in later problems, right, where we have to find out the derivative of trigonometric expressions. So there we have to use as a standard formula, so keep these things in your mind, right? And in next video we'll be finding out the more three trigonometric ratios that we have left still now, right? Derivative of the sec x, derivative of cot x, derivative of cosec square cosec x, right? So these all we'll be finding out. I hope you understand this, and you'll be keep on watching, right? So we'll be meeting in the next video. Bye bye.